Alright, today's lesson is on direct and indirect variations. So get out your notebook, write the title down, and we will get started. Okay, here are your notes. This is topic 3.5. This is direct and inverse variation. There are two types of variations, and they are direct and indirect. So write that down, direct and indirect variation. Remember, variation means that things vary. So direct variation means that as x increases, then y increases. So as x is going up, y is going up. Or as x decreases, then y will decrease. In other words, they're going to do the same thing. They are directly related to each other. I should say decreases. I'm sorry, it's messy. An example would be, so write the example down, the more hours that you work, so if that's x, the more you work, the more money you earn, which is y. Remember, y is dependent upon x. Y is always the dependent variable. Inverse variation is a little bit different. It means that as x increases, so x will go up, but then y will decrease. Y will go down. And that's called inverse variation. An example would be the more miles that you drive, the less gas in your tank. And that would be inverse variation. Both direct and inverse variation have a constant of variation. So write the constant of variation is k. Let's look at an example of this. So let's put this example in your notes. We're going to study this table. We're going to determine the type of variation, and then we're going to tell you what the constant of variation is. So you have hours worked. That's going to be your x of 5, 11, 14, and 17. And your hours worked is going up. And then your total pay is y. And if you look at the total pay is going up. So that would be an example of direct variation. So write that down, direct variation. Okay, now we want to find the constant. We want to find k, the constant of variation. If we take our y, our total pay, and divide it by the hours, so 30 divided by 5, I'll get 6. That means I'm getting paid $6 an hour. And it should be the same for each of these. So if I take 66 divided by 11, I get 6. 84 divided by 14, and I get 6. So my constant of variation, k, is going to be equal to 6. That's my rate of pay. The general equation for direct variation, make sure this is in your notes, is y equals k times x. That's your general equation for direct variation. So let's work some problems using this direct variation equation. So write the problem down. This is example 2. If y varies directly as x, so it's telling you that it varies directly, it's a direct variation, and y is 6 and x is 8, find y when x is 12. So what you want to do is you want to take your problem, y equals kx, and you want to substitute the y and the x that they've given you. So we're going to take y is going to be 6, and then x is going to be 8. And now we divide to find out what k is. And then we're going to use k to find out y when x is 12. Alright, so I divide by 8 on both sides. So that means my constant of variation is 6 over 8, and that can reduce, if I divide by 2, to 3/4. So my constant of variation is 3/4. The second part to this, it says find y when x is 12. So I take my equation, my direct variation equation, and I need to find y. So I don't know what y is, but I know my k is 3/4 and my x is 12. So now I just multiply, I can cross reduce, so I get y is equal to 9. And that would be my answer. So the key is knowing how to set up, knowing the equation, and then knowing how to set up the problem. Alright, so here is problem 3. The force required to stretch a spring F varies directly, so this is direct variation, with the amount the spring is stretched. Alright, so let's write our equation down. Y equals kx. So it says the force required to stretch a spring F varies directly with S. So we're going to replace the Y with F, and it varies directly with S. So we're going to replace the X with S. So now I have a direct variation problem with using the information in my problem. Alright, so F is going to be the force. It says 10 pounds is needed to stretch a spring 8 inches. Okay, so 10 pounds, that's going to be the force, so we put that there, equals K, and they give us to stretch a spring 8 inches. So that's going to be 8. So then it says how many pounds would be needed to stretch it 32. So the first step is to find K. So I need to divide both sides by 8. And then I would get K is equal to 10 over 8. And then we need to reduce that. If I divide by 2, I would get 5/4. So that's my constant, that's what K is, my constant of variation. Alright, now I'm going to plug this in, and I'm going to use F equals KS, and it says how many pounds, so that means I'm looking for the force, I don't know what the force is equal to 5/4 is my K, and S is 32 inches. So I multiply 5/4 times the 32. I can cross reduce, and I would get the force needed is going to be 40 pounds. And that would be the answer to your problem. Alright, let's try one more like this. If you want to pause and try it on your own and then check, you can. Alright, it says the distance driven varies directly, so it's direct variation, with the time traveled, T. So D, remember it's Y equals KX. So it says D varies directly with time. So I'm going to take D and replace the Y with the D and replace the X with T. Now I'm going to fill in my numbers. So if you've driven 175 miles, that's your distance, 175 for 5 hours. So I put that here. Now I'm going to find my K, so divide by 5. So K is going to be equal to, let's see, 175 divided by 5. So K is equal to 35. Now, the second part of my problem says, how long would it take to drive 210 miles? So, my formula is D equals KT. So, the distance is going to be 210 miles. That's the distance. How long would it take? That's the time that I'm looking for. So my K I know is 35, and then I have T. So this time I would divide by 35 to solve for T. So T is going to be equal to 6 hours. And that's how you solve it. Alright, let's do another example, example 5. I believe we might have 8 examples in this lesson. So example 5 says study the table below, determine the type of variation, and tell how you would find the constant of variation. So we're going to let X be the miles and Y is going to be the gallons of gas. So look at the miles, they're going up, so X is going up and the gallons of gas is going down. So this is an example of indirect variation. Indirect variation. Okay, so we need to find out what the constant of variation would be. So if we do the same thing that we did before, Hold on. All right, now the general equation for indirect or inverse, and I'm using those two terms as the same thing, is going to be y equals k over x. And that's the formula for inverse variation. So if I want to find the constant of variation here, I'm going to use y equals k over x. So here I have 10 is equal to k over, because I don't know what k is, I'm trying to find k over x, which is 18. So y is 10, is equal to k over 18. So I'm just substituting to find out what it is. In order to solve this, I'm going to have to multiply by the denominator on both sides. So I multiply this side because that clears that, and then I multiply on the left side 18 times 10. So when I solve, k is going to be equal to, I multiply those together, 180. So my constant of variation is going to be 180. All right, so let's look at 3 examples that involve this inverse variation or indirect variation. It's the same thing. All right, so write down this example. It says if y varies inversely as x, so that means we're going to use this formula, and y is 6 and x is 2, then find x when y is 4. So the first thing you want to do is find out what k is, and then you'll substitute it to find the other value. So here we have y varies inversely, so we have this formula. So now I just substitute. Y is 6, so I put a 6 here, and x is 2, so I put a k over 2. Now I need to solve for k, and I do that by clearing this fraction, multiplying by 2, and then I have to do that to the other side, so I can see that k is going to be 12. So k equals 12. Now I take this information because I want to now find x when y is 4. So I'm going to take my formula, y equals k over x, and it tells me that y is 4, so I put 4 there. I know that k is 12, and then I have an x in the denominator. And it's okay to have an x in the denominator. All I'm going to do, it's still a fraction, so I'm just going to clear this fraction. So I'm going to multiply both sides by x, this side by x. The x clears over here, so now I have 12 over 1, which is 12, so I'm going to finish down here. And on this side I have x times 4. Now I'm just going to finish this out by dividing by 4. So I get x is equal to 3. So that would be my answer. When y is 4, x is 3. All right, let's try a word problem here. Number 7. Number 7 says the volume of a gas at constant temperature varies inversely with the pressure. So the volume varies inversely with the pressure. So instead of using y equals k over x, I'm just going to replace the y with v. The volume, that's your volume, varies inversely with pressure. So I'll put k over p. Now I'm going to substitute my numbers. When the volume is 100 cubic inches, so I'll put 100 here. The pressure is 25 pounds, so I'll put k over 25. Now to solve for the constant of variation, I'm going to multiply both sides by 25 so that that cancels, and I know I do 100 times 25. So when I get that, I get the constant is 2,500. So that's my constant of variation. Now I need to find the volume when the pressure is 50. So I have my formula, B equals K over P. I'm going to find the volume when the pressure is 50. So I know that the I'm trying to find V. I know that K is 2,500. I know that the pressure is 50. So that means I just need to divide. And so my answer would be 50 cubic inches. And I know it's cubic inches because the problem, that's what I'm trying to find. And that would be your answer. All right, we have one last problem. I know this is long, but let's try one more. All right, number 8, the number of slices n cut from a bread loaf of constant length varies inversely as the uniform thickness of each slice. All right, so let's try to set this up. All right, so we know it says it varies inversely, and it tells you n varies inversely as t. So n goes first where the y is, and then you have a k, and then the t will be on the bottom. So let's fill in the information. So when there are 16 slices, n is the slices, so I'll put 16 here. And each slice is 15 millimeters thick, so K over 15 millimeters. And so now I need to find the constant of variation. I multiply both sides by 15 over 1 to cross cancel, and I multiply this by 15. So I'm going to get K is equal to 16 times 15. So that's 240. K is equal to 240. Now I'm going to come over here and I need to find the number of slices when the thickness is 12. So the number of slices is what I'm looking for. My constant of variation is 240, that goes on top, and I'm going to divide that by 12. So n is going to be equal to 240 divided by 12, which is 20 slices. So now you have learned about indirect and direct, or inverse and direct variation, and now you'll have some homework to do. Thanks for watching. Make sure you do a whisk. When and where did you watch the video? Summarize what you've learned, especially your formulas. Make sure you remember those and write those down again, and then any questions that you might have. Thanks for watching.